Experiment number 23. Test to identify nickel 2 plus, Fe2 plus, Fe3 plus, copper 2 plus, and chromium 3 plus ions using sodium hydroxide and ammonia. Objectives: identify the presence of these ions in aqueous solutions. To explain identification test using differences in solubility of the compounds. To identify the complex formation by certain cations. To identify the colors of D block element cations. Equipment and chemicals required for the experiment. Procedure: add diluted sodium hydroxide to the given cation solutions. A green color precipitate observes with nickel 2 plus solution. A green color precipitate observed with ferrous iron solution. A reddish brown precipitate observes in ferric iron solution. A blue color precipitate observes in copper 2 plus solution. A greenish blue color precipitate observes in chromium 3 plus solution. Then add excess amount of sodium hydroxide if a precipitate forms. A green color solution observes in chromium 3 plus ion solution, and all the other precipitates remain as previous. Observation and results. When we add sodium hydroxide dropwise, all the cation solutions will give their hydroxide as follows. When we add excess amount of sodium hydroxide, only the chromium 3 plus ion will give a green color solution as follows. Procedure: add diluted ammonia or ammonium hydroxide for the following cation solutions. A green color precipitate observes with nickel 2 plus solution. A green color precipitate observed with ferrous iron solution. A reddish brown precipitate observes with ferric iron solution. A blue color precipitate observes with copper 2 plus solution. A greenish blue precipitate observes with chromium 3 plus solution. Then add excess amount of ammonium hydroxide to the following precipitates. The precipitates of Fe2 plus, Fe3 plus and chromium 3 plus remains unchanged, but the precipitates in nickel 2 plus and copper 2 plus will convert to dark blue solutions. Observation and results. When we add ammonium hydroxide dropwise to the following cations, we can see all of them produced their hydroxides as given. When we add excess amount of ammonium hydroxide to the above formed precipitates, we can see only nickel 2 plus and copper 2 plus ions will give dark blue solutions. The reason for that is they can form their amine complex with excess amount of ammonium hydroxide. Procedure. Add potassium ferricyanide to the ferrous and ferric ion solutions. Ferrous ion solution will give a dark blue color precipitate. Observation and results. When we add potassium ferricyanide dropwise, only ferrous ion solution will give a dark blue precipitate. This is because due to the formation of this complex. Procedure. Add potassium ferrocyanide to ferric and ferrous ion solutions. A Prussian blue color precipitate observes in ferric ion solution. Observation and results. When we add potassium ferrocyanate dropwise, only ferric ion solution will give a Prussian blue color precipitate. This is because due to the formation of this compound. Procedure. Add potassium thiocyanate or ammonium thiocyanate to the given ferric and ferrous solutions. No change will be observed in the ferrous ion solution. A dark red or a blood red color solution observes in ferric ion solution. Observation and results. When we add potassium thiocyanate or ammonium thiocyanate dropwise, only the ferric ion solution will create this complex to give a dark red or a blood red color solution. Procedure: add dilute sodium hydroxide to, to the given chromium 3 plus ion solution. A yellow color precipitate observes. Then add hydrogen peroxide dropwise to the above precipitate. Precipitate dissolves and a yellow color solution observes. In the next experiment, add DMG to the nickel 2 plus ion solution. A red color precipitate observes. Observation and results. When we add sodium hydroxide dropwise to the chromium 3 plus ion solution, chromium hydroxide will precipitate and it is yellow in color. Then, when we add hydrogen peroxide, the precipitate will dissolve and a yellow color solution observes. This is because due to the formation of chromate ions. In the next experiment, we have to add dimethylglyoxime, which is known as DMG, dropwise to the nickel 2 plus ion solution. A red color precipitate observes. This is because due to the formation of this compound.